So, assignment 1, task 2 now is asking you to plot a graph. You've got some results. And when you plot a graph and put the results on, you're looking for, hopefully, a straight line, which represents a linear relationship between those two things. As one increases, the other increases at the same rate. Something that we'll be looking at next year when we look at Unit 28 is the ways of getting a graph that's a curve to look like a straight line. Because a straight line is so useful, we manipulate results to get a straight line. I'll plot one variable against another. We tend to plot the independent variable on the x-axis, which is the one that we can control, and the dependent variable, the one that depends on x, on the y-axis. It tells you in this assignment which one to plot on which axis, so there's no confusion. Plot the voltage on the horizontal axis, the x-axis, so don't make that mistake. If you get a set of results and it doesn't quite look a straight line, these are experimental results, and you get one rogue result, one over here somewhere, and you'd actually done the experiment, you would go back and check whether or not that result was correct, had I made a mistake. If you can't go back and check, and all the other results tend to be on a straight line, then what you would do is you'd ignore that result. You put a straight line through the results, ignoring the rogue result is something that you do. But if you find the results are sort of all over the place, well, not all over the place, but sort of a bit like this, then, as I'm sure you've done in the past, you sort of put the line sort of through the middle of them, yeah, okay? So, depending on the results, you decide what you're going to do, whether you're going to ignore one rogue result or they all look as though they're on a straight line, so then you put a line through the middle. And there's a lot of work that can be done around the question, you know, when is a set of results a straight line, or when is it actually random, you know? But we're not going to be looking particularly at that. What you're now asked to do is to establish the equation of that line and use the equation to calculate the expected power when the voltage is 30 volts. So what I'm after in this task is for you to plot the graph, to label the axes, putting the voltage on the horizontal axis and the power on the y-axis, establish the equation of the line and state what that is, and we'll talk about what we mean by the equation of the line, and write that down, the equation of the line. It's a formula, effectively, that then allows you to find the power given the voltage. And then once you've got that equation of the line, that formula, you can use it to calculate the expected power when the voltage is 30. And that's the power of something like this. And as far as engineering is concerned, this is done a lot. How do you arrive at formulae that relate power and voltage? How do you do it? What you do is you plot a graph of power against voltage. If you get a straight line, that's saying to you that there is a relationship between the power and the voltage. And then if you find the equation of the line, that tells you the relationship, the formula that then allows you to find the power. So a lot of the formula that you use in engineering, and you'll use more and more as time goes on, if you ask yourself the question, how is this formula arrived at, often it's this way. Okay. So quickly then, let me just summarize what's going on with the equation of the line, because I'm sure some of you have done this before, and then I'll stop the video and we'll look at in a bit more detail at the equation of the line. So the equation of the line if I plot a set of results and I get a straight line, I can find an equation for that line. It's assuming that this y and x is labelled y and x, and the equation of the line is y equals mx plus C. Now I'm sure that rings a bell with some people. Okay, the equation of the line. Anybody never seen that before? Right, okay. So, y is whatever's on the y-axis. X is whatever's on the x-axis. So if you're in this assignment, for example, plotting voltage on the x-axis, x will be V for voltage, and y will be P for power. Okay? So y and x are really the variables that go on here. On here, as I've said already, goes a dependent variable. So if you're unsure which one goes where, it's a dependent variable that goes on the y-axis and the independent that goes on the x. And more on that later. We'll talk a bit more about that. Anybody then that has seen this before, tell us what M stands for? The gradient of the line. Good. M is the gradient. The slope. So if I've got a slope, I can choose any 2 points on the line and draw myself a triangle. It doesn't matter where I choose the points. The bigger the better. It might be that you choose to use this point because that's a nice convenient one and draw the triangle like that. Okay? Anywhere you like, you can draw a triangle. Just choose convenient points so it's easy to read off on the scale what they are. And then once I've got my triangle drawn in, the gradient is y, how far you go up, divided by x, how far you go along. So the gradient is y over x. So this is y, and this is x. The only thing to be aware of is that the distance x is not this point. It's this value minus this value, that distance from there to there. Okay? So to get x, I subtract the lower value, which is this one, from the upper value here to get the length of x. And similar for y. So I read across from my scale to this value, and across from my scale to this value to get the distance y. Which is why you try and choose nice convenient points so you can easily read off what those values are and do the subtraction. Okay? So that gives us the gradient. That gives us this number here. Anybody tell us what C represents? Yes, exactly, where it crosses the y-axis. If x was 0, if we look at this bit here, if x was 0, then all of this would disappear. So y would just be whatever c is, and that will be, where is x 0? X is 0 here, so it's where the line crosses the y-axis gives us c. And it's called the y-intercept. So c is the y-intercept. And that's here. So that's all you have to do to find the equation of a line. You plot a graph. If you get a straight line, you draw a straight line through the set of results, ignoring rogue results. And then you find the gradients of the line, which will give you the value for m, and the intercept, which will give you a value for c. And then you can write down the formula that relates y and x. If the gradient turned out to be 3, for example, and the y-intercept turned out to be 5, then I could write that y equals 3x plus 5. And that would be a formula that would allow me to calculate y given x. Okay? Okay, so if you want to try some out and see if you can just check you know what you're doing, chapter 28 in the textbook require the exercise 113. Okay, and there's a work problem that you go through there, work problem 11, which takes you through the procedure in more detail than I've just done. Okay.